Welcome back. Today, we're exploring neural networks and deep learning, the real engines behind modern AI. If you've ever wondered how machines recognize faces, translate languages, or drive cars, this is the technology behind it. By the end of this video, you'll understand neural networks in a simple and intuitive way. Let's begin. What is a neuron layer? Deep learning models are built from structures called neural networks. And the basic building block of a neural network is the neuron, a tiny mathematical unit inspired by the human brain. A single neuron takes a few numbers as input, performs a calculation, and produces an output. When many neurons are connected together, they form a layer. There are three main types of layers. Input layer receives the raw data. Hidden layers, where the learning happens. Output layer gives the final prediction. A deep network simply has many hidden layers stacked together. How neural networks learn. So how does a neural network actually learn? The process is similar to how humans learn from mistakes. The neural network starts with random guesses, random weights. Then it compares its prediction with the correct answer. The difference between the network's output and the actual answer is called error. To reduce this error, the network adjusts its weights using an algorithm called backpropagation. Here's the learning cycle. Forward pass, inputs move through the network to produce an output. Calculate error. Backward pass, adjust weights to reduce the error. Repeat thousands or millions of times. Each iteration makes the network slightly better. Over time, it becomes extremely good at recognizing patterns, far beyond what humans can manually program. Activation functions. Neural networks need something that introduces flexibility, something that lets them learn nonlinear patterns. That magic component is called an activation function. Without activation functions, a neural network would behave like a simple linear equation. With them, the network becomes powerful enough to understand complex shapes, images, language, and more. Some popular activation functions include 1. ReLU, rectified linear unit. It outputs 0 for negative values and the input itself for positive values. Fast, simple, and widely used. 2. Sigmoid squashes values between 0 and 1. Useful for probability outputs. 3. Softmax, used for multi-class classification, like deciding if an image is a cat, dog, or car. Example, image recognition. Let's look at a real example, how a neural network recognizes an image. Suppose you show a neural network an image of a handwritten digit, say 5. Step 1, image numbers. The image is converted into thousands of tiny pixel values. These pixels become the input to the network. Step 2, hidden layers detect features. The first layers detect simple patterns, edges, curves, lines. Deeper layers detect shapes, loops, intersections. Even deeper layers recognize the entire digit. Step 3, output layer. The network outputs a list of probabilities for digits 0 to 9. Whichever probability is highest becomes the final prediction, for example, 5. The amazing thing is, the network learns all of this automatically through training. No one needs to manually tell it what a curve or edge looks like. Visuals, handwritten digit, pixel grid animation, feature detection layers, edges, shapes, digit, probability bar graph showing 0 to 9, final output. This looks like a 5. So that's neural networks and deep learning, the technology that allows machines to see, hear, translate, and make decisions. We covered neuron layers, how networks learn, activation functions, and a real example of image recognition. If you enjoyed this beginner-friendly explanation, hit like, subscribe, and share this video with someone who wants to understand AI from the ground up. Thanks for watching, and I'll see you in the next video.